So in this video, we'll have a look at variance and see how variance is influenced by the parameters that we have in binomial probability distributions. And that is the parameters n for number of trials and p, which is the probability for each trial. So I'm going to draw a variance function. So we'll try to draw the graph of the variance. And I'm going to start by defining the probability here. So probability is going to be p, and we'll just start with a value of 0.5 here. That's going to pop up here, and I want to be able to change this value. So I'm going to set up a glider. And we know that probability can go from 0 to 1, right? Let's make this glider vertical. I think that seems natural. Yeah, and that's fine, I guess. If we take a look at, oh, there it is. That's the glider right here. I've set up this graphic field to, we have our coordinate axis system here. So the first axis is the number of trials, right? And the second axis is the variance. And we're going to allow for maybe 20 trials here and see how the variance is going to change. Our variance function, the variance function, we'll just call that f for now. And it's going to, the variable that we want to use here is, let's see, the variable that we want to use, that's going to be n, which is the number of trials. And okay, so variance is a function of the number of trials. We used the formula that we introduced in the previous video. That was number of trials multiplied with the probability, which we have defined. And then we multiply that with 1 minus p, like this. So this is going to be our variance function. And GeoGebra translate this as a linear function where you have a number, coefficient, multiplied with the variable. And predictably enough, that's going to be a straight line. And now we can have a look at what happens when the probability changes. We're going to do that in a minute, but we could notice, first of all, what happens to the variance when the number of trials increases? When the number of trials increases. So here we have 0 trials, we have 1 trial, and the variance is going steadily upwards all the time. Yeah, so it increases. So as the number of trials increases, the variance increases. What if we change the probability as well? I could animate this glider and let the probability oscillate and move between 0 and 1. And you can see that, okay, as we approach 1 certainty that it's going to happen, the probability dips, the variance dips towards 0. And now we're back at 0.5. What happens when the probability goes down? Is the variance going to keep going up? it's starting to dip down again, right? So variance approaches 0 as the probability approaches 0. So you can see here that with a very low probability or a very high probability, there is little variance around the value of the variable. Whereas when probability is close to 50%, that's where you have the greatest variance. We're going to have a look at something else here as well. If we, okay, get this second example here. Okay, yeah. So this time, let's see, just delete this. We're going to set up another variance function, and this time the our variable is going to be the probability. So we're going to define n, the number of trials, and just set that to 10 first. So n equals 10, and then we're going to define our define our variance function. So we call it g, and g of p. No, sorry, g of p. Yeah. Equals n multiplied with p multiplied with 1 minus p. Okay, this looks a little bit different, right? We could set up a glider for the n here as well. So n changes between, well, we have the number of trials, right? So it's from 1 trial to a maximum of 20 trials. And okay, let's just show our glider here. What happens when we animate this glider? Okay, as the number of trials go up, you can see that the variance increases, like we saw before. But we can also see where the variance is greatest. And the variance is greater around the center here. And this is also where the probability is nearest 0.5. So as the number of trials increases, variance increases steadily. As the probability increases, well, when we get close to 50%, we have a large variance. And when we approach 1 or 0 probability, the variance drops off and becomes small.